fourth 17 now.
This is a project-based learning activity which uses an engineering challenge and a construction project combined with iPad technology to demonstrate how energy moves through residential homes in a unit that studies energy conservation. And make sure that the image fits in the screen. Energy transfer is a difficult concept. It's a very abstract line of thinking. And so we're trying to provide an experience for students where they can see how heat energy or thermal energy moves, and we put it in the context of a residential home so it becomes relevant to their life experience. You've been working for 3 straight days now on this project, building your models. And we're reaching the critical part now, which is the testing. All right, we're going to be collecting data now, okay, to see how the model can be used, okay, in this case to track thermal energy. But we need to pause for just a couple minutes and reflect back on why we're doing this. The integration of STEM in this activity begins with the science, the concept of heat transfer. We talked about how the potential energy in fossil fuels can be converted into heat energy and electrical energy. And this is the most useful form of energy to humans, okay, that we've found so far. We make that tangible by immediately beginning with an engineering challenge, which is to design and build this model home, which you will then use, as an engineer does, to test this system. Here's your objectives for the day. You're at a point now where you can actually take and examine the thermal images, and you're going to be identifying areas of great heat loss by using the contrasting colors in the iPad thermal imaging camera. The engineering now becomes more tangible as they use the technology, which is the iPad and the digital thermometers, to collect data. You do not want to get the temperature inside the structure. You want to measure heat that's moving out of the structure. So hold the probe on the outside of the windows and doors. Record the temperatures at a solid wall that doesn't have any openings in it, okay? Any window or door, all right? Any corner, okay, where 2 walls meet, and then along a roof line. Those are the 4 locations where we see the greatest amount of heat loss in homes and even schools. This happens everywhere, guys. And so they are taking that step to become bona fide engineers and testing their models to accumulate data that they can analyze and then solve the problem, which is, how do we make the home more energy efficient? Let's get to it. Mike, be careful with them. Handle them carefully, please. Yes, hi, right here. Whenever we build models in middle school, we have to keep it as simple as possible. So we start with balsa sticks, which students use to make their frame. And they just cover it with simple oak tag paper. You can use construction paper as well. Very simple, very, very easy to use. Hot glue guns, which we can borrow from the art department if you don't have them. A very simple thing, very inexpensive as well. And that's really all students need to build a model that they can test. In order for students to test their model, they need to have a source of light. And so we just use simple little shop lights that have clamps on them, and we just invert them and point them upward between the 2 tables. We create our own little light table, and students set their model over it when it's ready, and it is illuminated from within, and the heat moves and light moves out of the structure, and now they have a perfect scenario to run their thermal testing.
So you can see the heat coming out of that.
Students are instructed to take a series of photographs from different angles of the structure, the corners of the building, the roof of the building, windows and doors, that show, using contrasting colors, how heat moves through, and in this case, out of a residential home. As they're examining their thermal images, they're looking for red, areas of red color, and they're going to be very obvious in open windows and doors, but we want the students to actually focus on the not so obvious places, the corners of buildings, where the walls meet the roof, and the peaks of roof, what we call the roof lines. Here are places where poor construction really leads to a tremendous amount of energy lost in residential homes and buildings.
So for this, we definitely have to fix the top yet, and then we have to make the sides a little more stable and the windows.
It's not a true thermal imaging camera. It's actually a light imaging camera. It shows different wavelengths of light, but it serves our purpose in demonstrating that a closed wall in a structure will appear as a different color because the light is not penetrating, and whereas an open door or window, the light will appear differently because it's moving through that opening. And it's the movement of that light which simulates heat through that opening that makes the movement of heat energy tangible for students.
Well, where it's blue is where the least heat is escaping, but the green shows like where very little heat is escaping, and that's good because then it's like saving energy. When it's red, like in a window, it's like showing that like tons of heat is escaping there, and that like it's wasting like energy and money.
4 or 5 more minutes.
113.
It's important in science for students to understand that you cannot rely on one set of data for anything. You need to have multiple sets of data. And so by having students use temperature probes to measure the temperature at various places of the structure and then comparing it with the thermal images, they're looking to make connections and seeing patterns between the color in the structure and the increased temperature as the energy moves through.
This one is 104.9. So, is that the front window?
Yes.
Yeah. So there.
It's 90. That's insane. It's gonna be about 90 degrees, so you could rate 90 degrees there. And then in a corner, so I guess right here, because that's also gonna be a lot of heat flooding out because it's not very well made.
I purposely left the instructions vague for the construction part of the process and the design. Just some simple parameters on maximum height and maximum size so it can fit on the light table. I did this because I wanted them not to do a very good job in construction. I wanted the corners to be out of square. I wanted the roofs to be crooked. And I wanted them to be able to see that as a result of the poor construction, heat energy is lost in tremendous amounts.
This is about the same height.
Now their job is to make the home more energy efficient.
I think it's also escaping from there. So
Yeah, let's
you put another one over there.
Yeah, just a little bit.
Yeah.
One in the corner.
Yeah, do you want to add the hot glue?
They will learn about how to use insulation, and they will use cotton that simulates insulation, and they will hot glue it into the corners. They will push it into the roof lines. They will fill in the spaces between corners where heat energy is escaping. And more importantly, they will use paper, cut it out, and close windows and doors.
So should we bunch them together?
Just try and get all those gaps. We don't want any heat to escape.
Yeah.
So this house could be very
And then they will do a second round of thermal images, and they will compare the after images to the before images, and they're looking for changes in contrasting colors. So the areas that were previously showing red for heat energy was escaping will now appear differently, and we want them to notice that difference and to make connections and explain why it's different and what does that mean.
See, it turned more green, so that's how you know. And the blue, that's how you know it got cooler.
Yeah, this is all.
We still need to perfect on the bottom and top.
And really the key is for them to connect the idea that the reason that the colors are different is because heat is not moving through those closed doors anymore. And this really gets us right back to the science of heat transfer.
See, there's less heat coming out compared to the last picture as the heat is flowing out. But when we cover it up, the heat's insulated in and we don't waste money and pollute the environment.
One of the great things as a teacher is when you see students take matters into their own hands. And what you saw there in a couple instances where students had the idea, why don't we try some different materials? You know, we have cotton and we have paper, but what if we were to use just regular Scotch tape?
It seems more like you can see through it and sort of match the same.
yeah. That plastic could have some extra insulating properties rather than paper.
They said, Mr. Prato, the Scotch tape is much like the glass in a window. Why don't we try it? I said, sure, go for it. So they took it upon themselves to try that, and they came up with some interesting data.
We did tape, we did cotton, and we did paper, and then we just used normal space. And we recorded our data. And the tape actually works, is the most effective. And and then the open windows, obviously. And then the second best is the cotton, then go on to the paper, and then the open window is obviously the worst.
It's really about discovery. Students in science need to learn how to discover science on their own. And what I found in my experience is the project-based learning approach in a STEM format really provides the best environment for this type of discovery learning to occur. All right, guys, please listen up. May I have your attention, please? All right. Unfortunately, we have to start cleaning up, okay, because our time today is finished. But as you're cleaning up, and I can see some of you are already begun to clean up, doing a good job, on your data sheet, your temperature data sheet at the bottom are your constructed responses. These are really just, that's another way of saying a reflection question. The thing I want you to think about here now and respond to is, what does the thermal imaging and the temperature data suggest about how heat energy moves? Samantha?
Well, it moves out of cracks and openings, and sometimes we don't even realize it, and a lot of it's being wasted, and it moves, I guess, pretty quickly throughout these openings.
If the house is poorly constructed or the windows and doors are open, the furnace will just keep burning, and it's not keeping the house warm, and it's not benefiting anyone. It's just adding more pollution into the air.
Explain 2 ways in which energy conservation benefits you and your parents. Josh?
One way that energy conservation benefits me and my parents is that when you save the energy, you don't pay as much because you don't need as much to heat your homes.
Now, what's one way helps the environment, guys? This is really the big picture. How are we helping the environment by doing this? Gabe?
Well, we're helping out the environment because to buy the heat, we need to burn oil, and if we buy less heat, we burn less oil, therefore having the environment be better because we don't burn as much oil.
Science is tough because it's abstract and it's very conceptual. Bringing the abstract and conceptual into a tangible format is really the goal of a science teacher. And that is my focus as much as I can, is to get them involved in projects from which the science just sort of blossoms. All right, so please turn off your light stations. The hot glue guns can stay plugged in. Clean up your cotton and your insulation. Your tools get returned, okay, to the material station. Check the floor for scraps. Let's make this place neat. Great job. I'm very proud of you. Nice work.